Okay, we're going to continue with our unit on systems of equations, and what we're going to do is start talking about word problems, because as you've noticed from the homework, hey, there are a few word problems there, and what I don't want you to do is just skip over them because, darn it, you have to read. Well, guess what? In life, you're going to have to read. So where it comes to systems of equations, you might find that in the real world, this is probably the most applicable. What we're doing is in the real world, because in the real world gives you a variable, you can make an equation. And if the real world gives you 2 variables, you can make 2 equations. And if the real world gives you 5 variables, you can make 5 equations and find your way around to solve them. But we're not going to get that complicated. We're going to take these 2 word problems and go one by one. So in the first word problem, we have a group of 63 people attending a show. There are 15 fewer women than men. How many men and women attended the show? Now, you have to understand that the first thing for word problems, there are no shortcuts. There are no formulas. Okay, so with word problems, it's all about reading and thinking. Okay, so you have to read and think. And we're going to have to create equations. Okay, so no formulas, no shortcuts, reading and thinking. Okay? So now, we have our given word problem, and we have to think, can I create an equation? And in order for us to do that, I want to get a concept in front of you about creating an equation. Okay, so how is it that we can create an equation? I'm going to demonstrate something for you. So create an equation. And here's a demonstration. I'm gonna put a few writing utensils in front of you. Okay, so I have writing utensils here. Okay, hopefully you see them. And my question is, how many writing utensils are there? Okay, and you do the numbers, you count some things, and you find out, hey man, there's 5 writing utensils. Okay, so we have 5 writing utensils. Why does he keep using these big words for those things? And I'm going to ask you another question. Okay, so we have these 5 writing utensils. What kinds of writing utensils are there? Okay, so you look at this. The writing utensils are made up of markers and pens. Okay, so we have 5 writing utensils. Some of them are markers and some of them are pens. Okay, so we have markers and pens. Now, where did the number 5 come from? The number 5 came from the fact that we have markers and pens, and we have 5 of them. Okay, so how can we create an equation on this? Okay, so you might be thinking, because over the past 8 years, math has been driven hard and numbers. Well, take a step back from numbers. Don't think of the 5 as 3 plus 2. Think of the 5 as markers and pens. How can we create an equation? Well, based off of that, again, reading and thinking, there is no formula, there is no shortcut. If we have 5 writing utensils and we have markers or pens, that's an equation. That means if we have the number of markers plus the number of pens, we'd have 5. Okay, so the number of markers plus the number of pens is 5. Now, how can we make this a lot faster? If we introduce variables, well, that's going to make everything a whole lot easier. If we have variables and symbols, we can see an equation a lot easier. So we have to, give a variable for our markers. Let's say we call our markers M. All right, so we're going to call our markers M. And then we're going to call our pens P. Can we rewrite this equation using variables? Absolutely. If it's markers plus pens equal to 5, that means we have M plus P is equal to 5. Okay, that's the concept that we're dealing with. Okay, we're dealing with taking reality, breaking it down into something mathy, and then writing the equation based off it. And so we can write an equation based on anything. Okay, so again, this is the concept of word problems. We have to read and think. There are no formulas. There are no shortcuts. Okay, back to number 1. So we have a group of 63 people that attended a show. And there were 15 fewer women than men. How many men and women attended the show? The fact that we have a group of 63 people gives us a formula, or gives us an equation. So we have 63 people that attended a show. What kinds of people are there? Okay, so the people are made up of men and women. All we have to do now that we have our variables is assign or a constant is assign a variable to each thing. We have to, say something like maybe our men is X and then our women is Y. Let's just say. Okay, so we can invent variables. It doesn't matter. You can use M and W, A and B, P and Q. It doesn't matter. But call the men one thing, call the women another thing. But we have a total of 63 people. It came from men and women. And as we read and think, we can make an equation. That means if we took the total of men and women, if we added men plus women, X plus Y. If we took the total number of men and women, how many would we have? 63. Okay, so we have 63 people coming from the men and women. So take a look. We have an equation. We have an equation. But now, since we have two variables, we're going to need two equations. So let's continue reading the word problem. See if there's another equation we can make by reading and thinking. So we have a group of 63 people attended a show. Done. There were 15 fewer women than men. Interesting. 15 fewer women than men. What does that mean? Okay, so there are 15 fewer women than men. What was there more of? What are we going to have more of? Okay, so by reading that sentence, 15 fewer women than men, we can tell already we're going to have more men than women. Okay, so hopefully you can read and think and come to that conclusion. We're going to have more men than women. So no matter what happens, based off of that sentence, 15 fewer women than men, we're going to have more men than women. All right, so that's going to help set up this second equation. This is saying there were 15 fewer women than men. So let's say the men, again, still our variable, X. Okay, let's say we have X number of men. How does that equate to the number of women? We have the number of men. How does that equate to the number of women? There were 15 fewer women than men. And if there are more men than women, if we took the number of women, right, Y is women, if we took the number of women and we added 15 to it, we would have our second equation. Okay, we would have our second equation. Okay, so we were able to read and we were able to think and we were able to create two equations. Now there's another way to write this second equation. What if I was thinking more about the women? Okay, so what if I want to say the second equation? What if I want to say, well, the number of women equates to something? Okay, the number of women equates to something. And there were 15 fewer women than men. That means if I took the number of men and subtracted 15, I would get the number of women. So that's also another equation we could use. All right, but anyway, we're setting up two equations with two variables. And as long as we're reading correctly, we can interpret it. Okay, so this system of equations could look like x plus y equals 63 and x equals y plus 15. Or it could look like x plus y equals 63, y equals x minus 15. So we could have either setup, and we can solve that system through any of the means that we're using during this unit. Let's see if we can take that method, or at least understanding, and apply it to the second word problem. We have a store that sells shirts and shorts. One day, the store sold 90 total items and made $210. Shirt sold for $12, short sold for $18. How many of each item was sold? Oh my gosh, there's too many numbers, too many. All we have to do is read and think. Can we create equations based off of what we're reading? So a store sells shirts and shorts. One day, the store sold 90 total items. That is an equation. 90 total items. Okay, so we can pull an equation from that. What kind of items are there? There are shirts and there are shorts. Okay, so the total items comes from shirts and shorts. All we have to do now is assign a variable to them. Since I used x and y before, let me this time use a and b. So I can call the shirts A, the shorts B, and since there are 90 total items and it comes from shirts and shorts, that's a simple equation. That means I have A plus B equaling 90. So we have a two-variable equation. Now if we have two variables, we should have two equations. So let's go back to the word problem. So the total sale, okay, one day the store sold 90 total items and made $210. So the store is making $210 off of selling shirts and shorts. Shirts sold for $12 and shorts sold for $18. That's interesting. If shirts sold for $12 and we can say the word each, right? $12 each, and the shirts are our letter A, our variable A, and shirts sold for $12 each, that means if I'm selling shirts for $12, that means it's $12 each shirt. $12 per shirt. Okay, so that means $12 per shirt. And $18 for shorts. So my shorts are B, $18 for shorts. All right, so if I'm saying $12 times the number of shirts, $18 times the number of shorts, how much money did we make that day? $210. So the total comes out to be $210. And here we have a system of equations again. Two variables, two equations. One equation deals with the number of things, and the other equation could deal with the cost of things. But either way, as long as we're working in the same variables, we can make that system of equations. And if we have a system of equations, we can solve that system by using any of the means that we're going to get into. So when we are encountering word problems, this is what we can do. Okay, so again, in review, when it comes to word problems, there is no formula. There is no shortcut. All you need to do is read and think. Hopefully you can come up with the correct system. Thank you.